Hey everyone, Katrina here, and today we're going to talk about L'Hopital's rules for limits. Be sure to subscribe for more videos like these and watch to see the full example. Okay, so L'Hopital's rule really helps us out when we have problems with limits. So before we get into the definition, I'm going to take a second and show you when we would use it. So have you ever had a limit and you end up with an undeterminate form? For example, if you end up with something 0 over 0, or something that is plus or minus infinity over plus or minus infinity. In these cases, you don't really know what to do. How can you take the limit? Is it simply 0 or is it simply infinity? The answer is no. These are considered indeterminate forms. And when you get these two types of indeterminate forms, you can go ahead and use L'Hopital's rule to help you find the actual limit for your problem. So now that we've gotten that out of the way, let's go look and dive into what L'Hopital's rule is. Okay, so first of all, for L'Hopital's rule, let's get some of the mathematical housekeeping out of the way. So we state, suppose f and g are differentiable. So what does that mean? F and g are differentiable. That means that they each have a derivative. And we're also supposing that g prime, so the derivative of g, is not equal to 0 on an open interval containing a, except possibly at a. So essentially what this is telling us, if we translate from math language to regular language, that we have two functions, f and g, where we can find the derivative. And we are also supposing that the derivative of g is not equal to 0 on this open interval that we're considering. Okay, so we're considering an interval around a, and a is going to be where we're looking at our limit. So we're going to look at some limit, let's say as x approaches a. So we're saying that on this interval, on this open interval around a, our g prime is not going to be equal to 0. And it doesn't actually matter if it equals 0 at a, because just like what we know from limits, we're never actually reaching a. We're just getting infinitely close to a without actually ever getting there. So we don't really care. Sure, a can be 0, that's fine. But we care about the whole area, this open interval around a. And in that interval, it cannot be 0, or else it will hurt our problem. So let's go ahead. There's two different, situations that we're going to consider when we look at L'Hopital's rule. Because just like I said previously, there's two different indeterminate forms in which we can apply L'Hopital's rule if you have 0 over 0 or plus or minus infinity over plus or minus infinity. So we're first going to start to look at the condition number A, or part A, I guess. So if it says that if the limit as x approaches a of f of x equals to 0, and the limit as x approaches a of g of x also equals to 0, then, this is where L'Hopital's rule comes in, it says that you can take the limit as x approaches a of f of x divided by g of x, and that will equal the limit as x approaches a of f prime over g prime. So that's really, really interesting. So that's saying that this ratio of f over g, the limit of that ratio, is equal to the limit of the ratio of the derivatives of those functions. So we're hoping that after we take the derivative of these functions and look at that ratio, that we will not have an undeterminate form, that we will actually get a real value. So again, there's a bit of a caveat. This is provided that the limit on the right exists, or that it is equal plus or minus infinity. Okay, and then we can see that it has a very similar case over here, but instead of the functions equaling 0, they equal plus or minus infinity. So if we see that the limit as x approaches a of f of x is plus or minus infinity, and the limit as x approaches a of g of x is also plus or minus infinity, then we can do that same thing. We can say that the limit of f over g is equal to the limit of f prime over g prime, again provided that the limit on the right exists or is plus or minus infinity. So this is a really, really strong rule and can be used so much in calculus. So definitely make sure to take note of this. And if you're ever on an exam and you're like, oh no, I have 0 over 0 or infinity over infinity, know that L'Hopital's rule will be there to rescue you. So now that we've gotten the theory out of the way, let's look at a couple examples. So example number 1, we're going to look at our part A of the rule, and then we'll also cover another example that covers part B of the rule. So for example 1, let's consider the limit as x approaches a of f of x. Oh my goodness, I'm writing the definition out again. The example is the limit as x approaches 0 of sine 3x cubed over, what do we have, 4x cubed. Okay, so let's see what we have here. So if we were to go ahead and evaluate this limit right off the bat, what happens? So usually when you evaluate the limit, you would just plug in your a value into your function, and what would we have? We'd have sine 0 over 4 times 0, which is 0 over 0. So again, we end up with an undeterminate form of 0 over 0, so we're going to use L'Hopital's rule over here. So first of all, let's identify what is our f of x and our g of x function. So our f of x function is going to be what was on our numerator. So we've got sine 3x cubed. And then what is our g of x? So our g of x is what is on our denominator. So we've got 4x cubed. So now let's take the derivative of each of these and see what we get. So f prime of x will equal to, what do we have? We've got the derivative of sine is cos, and then we're going to have to use chain rule here, so we keep the inside the same, so 3x cubed, and then now we have to multiply by the derivative of our inside function, so that is going to give us 9x squared. Again, if you need some more background on chain rule or derivative rules, please be sure to check out my full derivatives playlist. I cover all the rules in a lot of depth, so check out that if you want some more background. Okay, and then now let's find g prime. So this we can simply use power rule. So we've got 12x to the power of 2. Or if I were to write that out, we'd have 4 times 3 times x to the 3 minus 1 according to power rule, which gives you 12x squared. Okay, so now that we've got our f prime over here, and we've got our g prime over here. So let's go ahead and use L'Hopital's rule. So we've got, I'll just say h rule. So now we are now going to look at the limit as x approaches 0 of f prime over g prime, because that equals the limit as x approaches 0 of f over g by L'Hopital's rule. So we're going to plug that in. So let's plug in our f prime over g prime. So here we have the limit as x approaches 0 of cos 3x cubed times 9x squared divided by 12x squared. Okay, so this is looking very promising so far. What can we notice right off the bat? Well, our x squares cancel out, which kind of saves us on our denominator. So our denominator is no longer going to go to 0. And what else are we left with over here? So we now have the limit as x approaches 0 of cos 3x cubed over 12. So now let's just go ahead and evaluate this limit. So essentially we're going to plug in the 0 where we see x. So we've now got cos 0 over 12. And I'm sorry, I forgot, we still have the 9 over here. We just canceled out the x's, but we still have the 9. So we've got cos 0 also times 9. So what is this equal to? Well, cos of 0 is 1. So we just have 1 times 9 over 12. and if we reduce that fraction, we've got 3 over 4. Look at that. So we went from having 0 over 0 to actually getting 3 over 4. So that's pretty amazing, and it shows you just how powerful L'Hopital's rule is. So as promised, I'm going to show you a example for our part B of the theorem. So we'll do example number 2. And again, if you're enjoying this video and finding it helpful, please hit that subscribe button. I really appreciate your support. Okay, so this example is a little bit trickier, so definitely make sure to watch it because this could be a great exam question. So we're looking in particular at the limit as x approaches pi over 2 from the left-hand side. That's what this negative represents. And then we've got x minus pi over 2 multiplied by tan x. Okay, so what happens here? So right away, we see, okay, we don't really have a fraction, so how could we apply L'Hopital's rule? So there might be some question marks going on in our head there. So what we can do is just amazing mathematical or algebraic manipulation, and we're going to turn this piece over here into a fraction. And I'll show you just how we're going to do that. So we have the limit as x approaches pi over 2 from the left-hand side. Then now we're going to have tan x as our numerator, and then our denominator is going to be 1 over x minus pi over 2. Because if you divide something by its reciprocal, that's the same as multiplying by that same number. So we're okay here. This works. Mathematically equivalent. Okay, so now we can see what happens if we were to plug in this value over here. We're going to end up with some infinity over infinity, which is not going to work out for us because infinity over infinity is another undetermined form, and that also tells us that we should be using L'Hopital's rule. And why is it infinity over infinity? Well, tan at pi over 2 is going to give us infinity because that is an asymptote. So that's why we've got infinity there. And then if we have pi over 2 at the bottom, then in the bottom we're going to end up with a 1 over 0, which is kind of equivalent to our infinity undefined situation. So that's why in this case we end up with infinity over infinity. Yeah, so definitely have to use L'Hopital's rule there. Okay, so following L'Hopital's rule, let's find our f of x and our g of x. So we're going to say that this tan x here is our f of x, and this 1 over x minus pi over 2 is going to be our g of x. So like we did last time, let's find f prime and g prime so that we can use L'Hopital's rule. Okay, so f prime of x here, so what's the derivative of tan? It's just secant squared x. And g prime, okay, we can use quotient rule here. So what do we get? We end up with negative 1 over x minus pi over 2 all to the power of 2. There we go. So now that we have both of these, we can use L'Hopital's rule. So we know that the limit of x approaches pi over 2 from the left-hand side. So we can take f of x, f prime, which is secant squared x, over g prime. As a result, our final answer is negative 1. So that was a bit of a trickier problem, but it shows that even if you don't explicitly have a ratio, you can create your own ratio and then apply L'Hopital's rule, which is an amazing skill to have. Yeah, so if you enjoy this video, please subscribe for more, drop a like, drop any comments that you have, and I do look forward to seeing you next time.